Assalamu alaikum, welcome dear student. Inshallah today we'll make a quick revision about some topics at our IGCSE curriculum. Okay, firstly let's talk about periodic table. For example, when we talk about periodic table, okay, we have to remember the most important groups, which are group 1 elements. Group 1, for example, group 1, group 7 elements, and also group 7, okay, like that, group 7 and group 8. So group 1 elements have one electron at its outermost shell, one electron at its outermost shell. Group 7 has 7 electrons in their outermost shell. Finally, group 8 have 8 electrons at its outermost shell. When you talk about reactivity of those three groups, we have to say that group 1 elements are the most reactive metals at the periodic table. The most reactive metals. Why? Because they tend to lose their outermost shell electron. Group 7 elements also are reactive, okay, because they tend to accept one electron and have a negative, okay, one oxidation state. Group 8 elements are not reactive. When we talk about group 1 elements, you have to remember some of them, such as lithium, sodium, potassium, rubidium, cesium, and so on. Group 7 elements, you have to remember fluorine, chlorine, bromine, and iodine. Double gases or group 8 elements, for example, helium, neon, argon, krypton, xenon, and so on. Okay, what about their reactions? When group 1 elements, or let's talk about their properties. Group 1 elements, when you move down the group, their reactivity increase down the group, and also melting point, okay, decrease down the group. Melting point decrease down the group. So when this group react with, for example, water, let's differentiate between lithium and sodium during the reaction with water. Lithium will react with water, it is react violently, okay, and give lithium hydroxide plus hydrogen gas. So when group 1 elements react with water, hydrogen gas is evolved. Okay, let's talk about sodium. Also, when sodium reacts with water, it gives sodium hydroxide, okay, plus hydrogen. So what is the difference between the reaction of lithium and the sodium? As we know, lithium comes first before sodium at group 1, so lithium is less reactive than sodium, or we can say that sodium is more reactive than lithium. So sodium reacts violently, or more effervescence or more hydrogen evolved during the reaction of sodium with water than lithium. Let's move to group 7 elements. When group 7 elements, okay, during the reaction of group 1 or group 7 elements, which start with fluorine, chlorine, bromine, iodine, and so on, let's first remember that atomic size increase down the group. At any group, atomic size increase down the group. So fluorine need to accept to gain one electron to get their outermost shell 8 electrons. So they need to arrive, okay, the electronic configuration of noble gases. So fluorine need 1 electron, chlorine need 1 electron. So if the atom has a small size, it will gain electron faster than the atom which have larger atomic size. So fluorine is most reactive than chlorine, most reactive. than bromine, and so on. So we can say that reactivity of group 7 elements decrease down the group, in contrast of group 1 elements. Okay, what about the reactivity of group 8 elements? Reactivity of group 8 elements, as we know, have 8 electrons at their outermost shell, so they are not they are not reactive. They are called noble gases. So let's talk about an important reaction for group 7 elements. Group 7 elements. Displacement reaction. Displacement reaction. What's meant by displacement reaction? Displacement reaction means an atom can displace another atom at its solution. For example, if we have a solution of HCl, hydrochloric acid, aqueous, plus Br2. Here we need bromine to displace chloride ion, or we need bromide ion to displace chloride ion. Okay, in fact, this reaction will not happen. No reaction. Why no reaction? Because here chlorine at group 7 elements is more reactive than bromine, so bromine will not be able to displace chlorine. But in contrast, if we have hydrogen bromide reacting with chlorine, hydrogen chloride is formed plus bromine gas. Why? Let's balance the reaction. We have here 2HBr, and here we have 2HCl. So bromine is less reactive than chlorine, so chloride ion can displace bromide ion, and these are the most important reactions of group 7 elements. So let's remember that, which is very important for group 8 elements. Group 8 elements is the uses of group 8 elements. Why? Because we have helium, for example, is used in balloon, and we have the other gas such as argon, or neon, which are used in bulbs, and so on. So it is very important to remember the uses of group 8 elements. So again, the most important groups at our curriculum is group 1 elements, group 7 elements, and you have to remember the difference between group 1 elements densities. So we have to understand that density of sodium, for example, or potassium, and firstly sodium, potassium, cesium, for example, as we know here, density will increase down the group, density will decrease down the group, so let's move to group 2 elements, which starts with beryllium, magnesium, calcium, and so on. So what about the reactivity of this group? We say that metals of group 2 elements is less reactive than metals of group 1. For example, magnesium, for example, react with H2O, giving magnesium hydroxide plus hydrogen, and this reaction, we called it, occurs slowly, يحصل ببطء, slowly. Okay, in contrast, group 1 elements or all group 1 metals react with water violently, okay, with the reaction occurs hastily. So, to understand the difference between group 1 elements or group 7 elements, we have to remember that the atomic size at any group increase down the group, okay, but at group 1 elements we need to lose 1 electron, but at group 7 elements we need to gain electron. Group 1 group 7, group 7, here we need to gain 1 electron, to get the outermost shell 8 electron. At group 1 elements or metals, we need to lose 1 electrons, okay, 1 electrons, okay, to get also the electron configuration of the elements like the noble gases. So here, as we move down the group, atomic size increase, so reactivity decrease at halogens, reactivity decrease. But at group 1 elements, as we move down the group, reactivity increase. The ability of atom to lose its outermost shell increase. Reactivity increase. So let's move to another topic, which is called reactivity series. Reactivity series. At reactivity series, which start with, for example, lithium, okay, sodium, potassium, magnesium, or let's do right, calcium, magnesium, okay, zinc, okay, lead, iron, carbon, hydrogen, okay, and then copper, silver, and gold. Here at reactivity series element, as we moved down the reactivity series, okay, the reactivity decrease. As we move down this reactivity series, the reactivity of elements will decrease. But let's here it is lithium, okay, and here. So I have to arrange them according to their reactivity. So the reactivity of potassium is more than sodium, okay. Reactivity of potassium is more than sodium because potassium below sodium at group 1 elements. So potassium, sodium, calcium, magnesium, zinc, lead, and why did I arrange them accurately? Because at reactivity series, okay, displacement reactions occurs according to their arrangement at reactivity series, or displacement reactions occurs according to the arrangement of metals at reactivity series. How? Metals such as calcium, for example, okay, when we act with magnesium chloride, Okay, for example, calcium here more reactive than magnesium, so it can displace magnesium, forming calcium chloride plus magnesium plus what? Plus magnesium, and so on. During the reaction, for example, of copper oxide, okay, with carbon, here attractive series, carbon is above copper, so here we will form, okay, CO2, we'll move here, see, CO2, okay, plus copper solid. So there is a displacement reaction here. The most reactive element at the reactivity series can displace the least reactive element. So it is very important to remember reactivity series elements and their reactivity. Okay, let's move to another topic, which is talking about extraction of metals. For example, the extraction of metals. When we talk about extraction of metals, we have to remember the most important ores. For example, aluminum. Aluminum is found as aluminum oxide, Al2O3, which is called bauxite. Iron is found as Fe2O3, iron oxide, hematite. Okay, hematite. And for example, zinc is found as zinc sulfide. It's called blende. So when we talk about extraction of those metals, aluminum or zinc or iron, we have to remember two processes. There are many elements are extracted. Okay, are extracted by electrolysis, and another metals are extracted by reduction with carbon, So metals which are extracted by reduction with carbon are, for example, iron. Okay, metals which are extracted by electrolysis, here we are using electrolysis cell, which consists of positive electrode and negative electrode, cathode and anode, immersed in a solution or aqueous solution. Okay, so such as aluminum or aluminum, for example. So you have to remember that during the extraction of iron, we will obtain at the end, okay, or at the furnace or blast furnace, will obtain iron as a liquid contaminated with carbon and also with silica or silicon dioxide, SiO2, sand. So extraction of iron should, okay, moves to another process, okay, which enable us to obtain steel and alloy. At this process, liquid iron from blast furnace, okay, liquid iron from blast furnace, okay, will expose the two a high current of oxygen, O2, which react with carbon, which is mixed with iron. Okay, after this process we will obtain iron plus a particular concentration of carbon. which detect the type of alloy, if it is steel or another alloy. So if we are going about talking about some questions, firstly you have to talk about the function, okay, of blast furnace, the function of blast furnace, with the rule of blast furnace to obtain a liquid iron which is contaminated with silica and carbon. So why second step, which include exposing liquid iron, which is resulted from blast furnace to oxygen to remove contaminated carbon. And also we use during this process calcium carbonate, CaCO3. Calcium carbonate, okay, which is called the limestone. As you know, limestone during the thermal decomposition gives calcium oxide, which is lime plus CO2. Okay, what is about the role of calcium oxide during the extraction of iron? Calcium oxide react with silicon dioxide, SiO2, and form calcium silicate, okay, which is slag. Okay, CaSiO3, calcium silicate. Okay, so the role of calcium oxide or limestone at this process, or first process or second process of iron extraction, is to remove, okay, impurities or acidic impurities. Acidic impurities. يبقى rule of oxygen, remove carbon during the extraction of iron. Rule of calcium oxide, remove SiO2 or remaining of sand or silicon dioxide. So it is very important to remember the extraction process of aluminum and iron. Let's move to another topic, which is test cations and anions. During the test of cations and anions, we have many tests. Test for elements, test for metals, such as sodium, for example, which is called the flame test. Flame test including, okay, put the metal, okay, on a flame test, on a flame. So sodium will give yellow color or yellow flame, and so on. Lithium also will give a red flame, and potassium will give a lilac color, and the copper will give green, and so on. So let's move to cations, for example. To test the cations mean here to test metals, ions such as calcium ion at its solution, such as CaCO3, for example, or CaCl2, or aluminum cation. To test all of those cations, we use two solutions: sodium hydroxide or aqueous sodium hydroxide, and ammonia. Okay. For example, if we test iron to sodium hydroxide in NaOH, it will give green color, insoluble in excess. Okay. If we test copper with NaOH, Also it will give green color. Okay, so you have to differentiate between them. Which one will be soluble in excess? Which one will be soluble using ammonia? So it is very important topic. You have to understand how to differentiate between different anions, such as negative CO3, negative ion carbonate. How to differentiate between carbonate and sulfate, for example. Okay, the most important cation used to differentiate sulfate is using barium. Okay, barium cation, because barium sulfate, for example, is insoluble, white precipitate which is insoluble. Carbonate at all, when use acidified solution with HCl or HNO3, okay, CO2 is evolved, carbon dioxide, okay. Turbidity of lime water, you have to remember that at the presence of carbon dioxide at lime water, it becomes turbid, okay, or it causes turbidity of lime water. So from the very important topics here also is importance or the pollutants, such as NO, SO2, lead, for example. All of those pollutants, lead, for example, cause brain damage. Lead has no effect on respiration process but affect the brain damage. SO2 cause irritation or irritate eyes, okay, and make what's called acidic rains. But nitric oxide, okay, will combine with hemoglobin, instead of oxygen, and cause poisoning. Okay, so we say that nitrogen oxide is poisonous. Okay, so it is very important to remember that the steps of preparation for Gratin H2SO4 contact process, which starts by the reaction of sulfur and oxygen to give us SO2 sulfur dioxide, then the reaction between sulfur dioxide with oxygen, okay, to give 2SO3 or give SO3, this reversible reaction, and the formation of helium, and finally formation of H2SO4. It is very important to remember the catalyst which are used here. If it is iron or vanadium, okay, the temperature 450 or another thing, and remember the atmospheric pressure, okay, which is 2 atmospheric pressure or 200 as ammonia. So during the revision process we have to focus on the most important points which may come at the exam. From the most important topics at our curriculum is energetics. When we talk about energetics, we have to remember the exothermic reaction, okay, and endothermic reaction. During the exothermic reaction here, the energy, okay, the energy which released during the breaking the bonds, okay, is greater than energy which is released during making new bonds. So you have to understand or remember the position of reactant and the products at the curve, and the direction of the enthalpy change. For endothermic reaction here, the position of reactant and products, okay, will change, and also the direction of enthalpy change will change also. So, because during the endothermic reaction, the energy required to forming the bond is greater than the energy, okay, which you need to, or the energy which needed to break the bond is larger than the energy, okay, of making the bonds. So we have to remember during this process of exothermic reaction, endothermic reaction, two examples. For example, reaction of sodium with water, which is exothermic, or burning of fuel such as methane, okay, with water, with oxygen, gives CO2 plus H2O. This exothermic reaction. And remember the endothermic reaction for calcium carbonate, for example, okay, which is endothermic reaction. It's thermal decomposition of all carbonates, calcium carbonate, which give calcium oxide plus a carbon dioxide. Those are the most important topics you need to study, okay, or focus on during your exam. And remember the concentrations of oxygen, nitrogen at the atmosphere. So good luck at your exam, my dear students. Inshallah, we will make a quick revision after that about the next topics, inshallah, when we finish it. Thank you very much.